Hello everyone, today we are going to see the electric discharge machining, which is non-traditional machining processes. But before that we will see the difference between traditional machining processes and non-traditional machining processes. In traditional machining processes, the material removal takes place due to the application of cutting forces, where in non-traditional machining processes, there it uses the different energy domains to provide the machinings. And another point is that in traditional machining process, the cutting tool is harder than the workpiece at room temperature, and in non-traditional machining process, the tool need not be harder than the workpiece material. And the another point is that in traditional machining processes, the high tool wear occurs, where in non-traditional machining process there is no any tool wear happens. So there are so many non-traditional machining processes are there, that is abrasive jet machining, ultrasonic machining, electrochemical machining, electro discharge machining, laser beam machining. Out of that, today we are going to see the electric discharge machining. But before that, we will see the different components of the electric discharge machining. Okay, so there are different components, as you can see in the diagram. Tank is there. Okay, in tank there is fixture is there, and on fixture the work is mounted. The purpose of this fixture is to hold the workpiece. Okay, and if you observe in tank, the dielectric fluid is there. Okay, we will see in working what is the use of this dielectric fluid. And above this, the tool is there, and above this tool the servometer is connected. Okay, and apart from this, a DC source is there, which has two terminals, positive terminal and negative terminal. Negative terminal is connected to the tool and positive terminal is connected to the workpiece. Now we will see the working of this electric discharge machining. Okay, when this supply starts from the DC source, the work liberates the metal ions to the tool. Metal ions, and the tool liberates electrons towards this work, which is at very high velocity. But in between these two, the dielectric fluid is there. So in this, ionization takes place at this moment, and due to the ionization, the spark generates, and the spark generates about 8,000 degrees Celsius to 12,000 degrees Celsius heat. This heat is used to melt the work over here. Okay, this is how the electric discharge machining works. But if you observe, the servometer is there. What is the use of this servometer? Okay, this question arises. The use of this servometer is that to control the movement of this tool. Okay, so this is how the electric discharge machining works and how the machining occurs at the work. Okay, thank you.